There's some great new enhancements in this release of RSpec, and we're going to go through them in this video. The first one involves this subtract background command. There are now two different spinner boxes instead of one, and that allows you to control the number of rows above being different from the number of rows below. One circumstance where you might use this is if you had an intervening star below the spectrum but not above, so that you could adjust the number of rows below to be somewhat less than above. Here the rotate command now is down to a half of a degree. You can see the 0.5 degrees there as I slide it. That gives you a little more precision when you're doing your rotating. Now here's a real time saver. You know what a pain in the neck it can be to climb around Windows from folder to folder looking for a specific file. Well, now here we have this recent option that will show you the recently loaded files for this command. There's also a little pull down arrow up here for .dat files, as well as an arrow here for video files or image files. Now if you click with the Shift key down on your keyboard, that will clear these lists. Now I want to take a look at another file that we want to process. We're going to look at this Europa that's been cropped. It's a FITS file from a high resolution spectrograph. And you can see over on the right here, our camera goes up above 2600 pixels across, so there's a lot of data there. On larger images like this, especially on slower computers, this histogram adjust can be a little sluggish. You can see it's having trouble keeping up with the mouse. Well, we've added this live update checkbox. If you turn it off, the software won't update the screen till you let go of your mouse. So it's much smoother in making adjustments, especially if you're on a very large image on a computer that may not be the fastest computer. Now over here on the live camera tab, we've got the camera lens covered for this video. On some cameras like the Celestron Next Image or the 2Cam, making a change to resolution or to frame rate here in RSpec wasn't affecting the camera. Now when you select either of these options, the software will prompt you whether we should stop the camera while you're making those adjustments. Now those adjustments will be accepted by the camera and applied to your video. Next, let's come down here to the image file tab because we're pretty much done with everything on the left. So I'm going to just select, this happens to be Vega. We'll just tune things up a little bit so we have something pretty to look at. Get our capture box around the image, and we'll go into Calibrate. Now here on the Calibrate screen, I've got the 1-point alignment set, and I'm going to put in an angstroms per pixel. Now one enhancement in this release is this number now sticks here between runs, so you won't have to retype it in when you come back to this screen. Okay, now I'm going to click on Apply and Close. We'll take a look at the resulting screen. Now the enhancement that I wanted to show you here is if your angstroms per pixels is less than 10, RSpec now shows it to additional degrees of precision to the right of the decimal place. Now let's come back just to remind you, here on the Nonlinear tab there's this new option, Show 1-Point Calibration Window. It's a very powerful feature and it's described more completely in a different video, so check that one out too if you would. Now here under Appearance there's a handful of nice new enhancements. Here under Graph, for example, there's this new checkbox, Legend Visible. You can see over on the right the legend coming and going. Now the legend can be helpful, especially if you have more than one line on your graph. You can highlight it by hovering. But by turning it off, you get a little bit more screen real estate. It makes things a little bit easier to see when you're working. In order to show you this next new feature set, we need a calibrated profile. So I'll click on Calibrate. I already have numbers in there, so I'll just click Apply and Close. Now let's go back to the Appearance screen by clicking on this button. Now we're on the Graph tab, but we're going to go over to the Labels tab. And you'll notice this looks considerably different than it did in previous releases. At the top here, instead of having a pull-down box, we now have a list of every label that's available. See, there's 24 here now rather than 12, and a pull-down box just was too clumsy. It was tough to navigate, it was tough to see your data. Now we can just click on any button like this and then fill in the details at the bottom of the screen as we've done in the past. So for example, this could be hydrogen, and then I'll right-click Hydrogen Beta. Now for the wavelength, as usual, I can just click on the item right on the profile, and we've got our wavelength filled in. Now I could move on to the next one. Now notice that these arrows here will let me navigate these radio buttons. Also notice that the radio button takes on the label that's identical with the way we defined it down in the bottom. And again, that makes it much easier for you to navigate through this data. After you get used to this screen, I'd like to hear from you what you think of it. Does it make it easier for you to customize your profiles? Now here on the elements list, there's been a change. I'm going to select hydrogen bomber, and then this tab here, details, will show me the wavelengths and the names of the items. Now these are items that you can customize if you want to. Okay, let's start with a clean slate. I'm going to click on blank all labels, and that will erase everything up here on the top. Now we're starting from scratch. Now I can click and drag any of these wavelengths over to the label screen on the left. It saves you typing. When I let go of my mouse, you can see hydrogen beta in 4861. The wavelength was also filled in. Now you may not like just the hydrogen beta there. You may want to see the wavelength displayed on the profile. So what we can do is come down here to the settings button. Let's drag it onto the screen here. And you can see there's 4 different formats that you can use when you're taking items from this details over to the left. So now let's go on to a new label. In fact, let's blank all labels so we start from scratch again. Now I'll just double click this time, and you can see when I double click, the text reflects that selection I made a moment ago on the settings screen to get both the hydrogen bomber label and the wavelength. And of course we can slide these around just like we've done in the past with labels that we put on our profile. Now these 2 new checkboxes are sort of neat. When you check them, look over on the right, you can see those lines extend to the top and bottom. Let's change our colors here a little bit. First of all on our labels, like that, and we'll copy it to all the other labels so they all have the same color. And then down here on symbol, we'll change the color here, and then use this new button to copy the symbol color. So now we've got a nice clear symbol. You can see we can turn one on and off as we please. So what's cool about this is, if we come over here and as we double click on the right here, it's filling in the text area and updating the graph automatically. Of course, if we wanted to see all of the hydrogen bomber element lines at once, we could put a checkbox here. But that's a temporary display, whereas when we drag them over to the left to the Labels tab on the Appearance screen, they remain in the drawing even when we close this right-hand window. If you're using the neon data that we ship with the product, you'll see that the file has a little bit different wavelengths in it. They're a little bit more typical for what an amateur spectroscoper would use. They should be helpful for you. Let's close this screen and show you a similar function here on the Calibrate screen. I'll drag it on. We can take any of the wavelengths over here. Let's go to hydrogen bomber and look at the details. And now over here in this list, by double-clicking or dragging, I can drag any wavelength I want. There's 486133. There's a 6562. I can come up here. Watch what happens here. I'm going to double-click this time. So the software is saying, wait a second, that's a pixel field. You can't paste a wavelength in there. So we'll click on a wavelength field and the paste gets done. So this is really neat, this new capability of using the details button. We think it'll make it much easier and more fun and faster for you to customize your profiles. Back to the main screen again. I'm going to copy this image to the clipboard using this button that's always been available. And now we're going to jump into Word and see what that image looks like when we paste it. What I wanted to show you here was over on the right, this new little logo that says created in RSpec with the version. This little banner will help get the word out that a great spectroscoper like you is using RSpec to do some of your work. Let's go back into RSpec and we can look at how we can control that banner. Here on the options screen, you have the option to select whether you want it on the right side vertical or horizontal or on the left side, and you can even turn it off. Of course, we'd prefer that you leave it on so that people see that you're using RSpec. There's another enhancement to RSpec that you can turn on this screen, and that's this full 32-bit processing on FITS images. In the past, RSpec would scale your images down to fit within a certain range, and although no data was distorted, occasionally some minor details in the spectra could be hidden. Let's take a look at this image, which illustrates it very clearly. Now here on the left, look how small those ADU y-axis numbers are. That's most likely because there was a bright star in the image, so everything else scaled down relative to that star. It's when this scaling occurs that RSpec in the past would round intensities up and down and there could be some data hidden. Let's take a look. Here you can see the flat lines that occur in different places on this image? That's a tip-off that there was something going on that got rounded off while RSpec processed the image. And over on the right here we can see the same thing, some horizontal lines that occurred because RSpec scaled into a narrow range. So let's go over to the options screen and turn on full 32-bit processing. Notice first of all that these y-axis ADU numbers are much larger. These are the actual numbers in the FITS file, which represent the flux on your sensor. When we zoom in, we can see that those horizontal lines are gone. There's now complete fidelity between this data and what was in the FITS file. So using the 32-bit FITS option to process images in RSpec will give you a more accurate presentation of your data. The downside is the program will run a little bit more slowly because there's a lot more data to be processed in 32 bits. So unless you see evidence of that flat topping we saw earlier, because your data has a very wide dynamic range and you're looking at very low levels, you're probably best served by just leaving that 32-bit option off for faster operation of the program. Also, if you're doing this kind of high precision spectroscopy, of course, you shouldn't be using a rotate command because rotating an image can introduce artifacts. So make sure that your grating or your spectrograph slit is oriented so that the spectrum is smeared exactly horizontally across your sensor. Now the feature we're going to look at next is an advanced feature that most people won't need in day-to-day work. But if you're exporting nonlinear calibrated profiles to a third-party program, you'll need to know about this. So here on the options screen, there's a checkbox, linear X values when exporting to a DAT file. For most of you, you should just leave that option off. But let's see how that option affects things. I'm going to increase the point size and make them visible so that we can see what's going on here. And then I'm just going to zoom in by Shift. Now as I hover over each point, since we're not calibrated, each point is a pixel value, and the step from point to point, the X value changes by 1. So this is linear at this point. Now let's do a calibration. I'm going to do a nonlinear calibration and do it pretty quickly and sloppily here. It doesn't really matter for the purposes of what we're doing that it be exactly accurate. These are our favorite hydrogen bomber lines that we've come to know and love. And I'll do a second order calibration, nonlinear, could be third or fourth. And now I'll click on Apply and close. Now let's zoom in. Now the points are the same, but because it was a nonlinear calibration, the number of angstroms between each point, how much it changes, could vary from point to point. Now I can't do the math as quickly as that little box is popping up, but that's the point of nonlinear calibration. That from pixel to pixel the gap changes in terms of how many angstroms difference there is. Now all of this works fine inside of RSpec, but if you're going to export this to a .dat file to read into a third-party program like VSpec for example, these steps have to be linear. They have to all be the same gap from x1 to x2 to x3. Let's export this. Now we had that checkbox on in options, so it's going to make the adjustments to turn it into a linear export. And now let's read it back in and compare it to what we have on the screen right now. And we'll zoom in. Have to go pretty far in, there's a lot of points. Now as we hover over each point, the step from point to point is exactly the same. It happens to be 1 here, but the fact that it's the same step means this is a linear export and other applications can read this data in. Now there's too many points here, it's oversampled, but that shouldn't be a problem with most software. And in fact we've lost some data because now in RSpec we don't know which points came from the sensor and which were a result of filling in the gaps for that export. So I'd encourage you leave that checkbox off when you're using RSpec unless you're going to a third-party program.